Hello friends, my name is Anuruddha. So today we are going to discuss about unit number 2, machine instructions and programs, lecture number 10. Now, let us go to the contents that we are going to discuss in this lecture. First, we are going to discuss about the additional modes and what is assembly. So let us go through which are the modes other than index, relative and immediate modes, which are called as additional modes. So other than additional modes, there are two modes useful for assessing data items in successive location. So if you want, suppose there are two data that are present successively in locations. So if one data item is present at 9th location and another data item is present at 10th location. So I want to successfully assess the data item. For that purpose, there are some additional modes. So the first additional mode is called as auto increment mode. Now the effective address of the operand is the contents of a register which is specified in the instruction. So in the last lecture I told how to find the effective address. It's present in the contents of the register which is specified in the instruction. So once we have done with the effective address, that is indirect addressing. So after we can assess the operand using indirect addressing, we can increment the contents of register automatically so that it can point to the next location. So if to do that we use auto increment mode. So auto increment mode can be denoted by putting a specified register in parenthesis, means it shows that the contents of the register are used as effective address followed by a plus sign. So as you can see in the example, it is written like this, that is Ri is some register. The round brackets indicates that we are trying to find the effective address. So after finding the effective address, we are incrementing the register value. So if the register is present at the location 20, it will be incremented to 21. Only when we find the address of the operand or when operand is used, afterwards the address will be get incremented. So by default the increment amount is 1. So this mode is useful in assessing successive bytes of some memory location. So if the items are present at successive location, we can use this additional mode. So as you can see in the example, it is nothing but a list of students. Suppose n stands for the list of students that are present. Then it is moved into register R1. Now we are moving the contents, that is address of the first number, that is first number that is present in location in num1. So we are moving the address into R2. Now R2 contains the address of number 1. Again we are saying clear R2. Now it is entering into the loop. So we are saying add R2 in bracket plus comma R0. So what does this mean is R2 now initially contains the address of first number. So after using the round bracket, it will now use the indirect addressing mode. So as we have discussed what is indirect addressing mode, it is used to find the effective address of the operand. Now R2 contains the address of number 1. So number 1 address is used to find that operand. So after finding the operand, the value of R2 is incremented. That is, now R2 will be pointing to number 1 address. After incrementing, it will point to the next number. So it will get incremented. Same it goes for the second number. So this is how additional modes are. Now we'll go for second additional mode is auto increment mode. Here the contents of registers are specified in the instruction are first automatically decremented and are used as a effective address of the operand. So here it is the reverse process of auto increment mode. So in auto increment mode, first we are going to find the effective address of the operand, then we are incrementing. But for here what we'll do is first the contents of the registers are specified in the instruction. That is, first we first it automatically decrements the register contents, and then it is used to find the effective address of the operand. So it is denoted by putting a specific register in parenthesis preceded by a minus sign. Minus sign, it indicates the contents of the register will be decremented before it is used for finding the effective address. So it is denoted by, as you can see here, minus bracket r, means first the content of ri is decremented. So if it is at the fifth location, it is first decremented to 4, and then we find the effective address of the operand. So in this mode, operands are assessed in descending addressing order. So first we decrement the address and then we find the. Now you go for what is called as assembly language. Now machine instructions are represented by pattern of zeros and ones. Symbolic names are used to represent the pattern. So machine language are used in the form of zeros and ones. So humans can't understand the language of zeros and ones, so we use the symbolic names to represent the patterns. So whenever programs are written for a specific computer, there are some acronyms which are used, which are called as mnemonics. So move, add, inc and br. So these are called as the mnemonics written in the program. A complete set of symbolic names and rules in a programming language are referred as assembly language. So whichever symbolic names, as I said, a set of symbolic names as well as how to write the programs, the rules which are given are together are called as the assembly language. Now a set of rules for using this mnemonics. So how to use these instructions or mnemonics? What are the rules of using those mnemonics in the program? So that rules is called as a syntax of the language. Now whatever the programs written in the assembly language can be automatically translated into a sequence of machine instructions. So that is done by the assembler. So as you know, whenever you write a program, it will be converted into a sequence of machine instructions. So assembler, what we do is, it will convert from assembly language, whatever we write the assembly language, into a machine instruction or machine language. So that is done by the assembler. So assembler is stored as a sequence of machine instructions in the memory of computer. So the program will be first converted into an assembly language. Then the assembler will convert the assembly language into a machine instructions. Now whenever user program is entered into the computer through a keyboard, so whatever the program he has done, it will be stored in magnetic disk. So user programs is nothing but a set of alphanumeric characters. So when we write the program in the form of alphanumeric characters, it is stored in magnetic disk. So when the assembler program is executed, so it reads the user program, analyzes and then generates the desired language program. Whenever you write an assembly program, it first reads the user program which is written in alphanumeric characters. So after reading it, the assembler will convert it into a machine language program. The user program in original alphanumeric text is called as a source program. So whenever the user writes a program, you can say a C or Java program. So whatever it is called as a source program, the program written by the user. Now assembled machine language program is called as object program. That is, the program which has been converted into a machine language is called as object program. Now example, a move instruction is written as you can see, move r0 comma sum. That is, it moves the contents present in the register r1 to r0 to sum. So here the mnemonic move, it will represent the binary pattern which is called opcode. So in binary, move will represent which is called as opcode. So instead of move, in binary it is called as a opcode. It is used for performing operation by the instruction. So what this assembler does is, it will translate this mnemonic into binary opcode. So move will be transferred into binary opcode, which will be understood by the computer. Now the opcode mnemonic is followed by at least one blank space character. So here you can see there is a one blank space character. Then the information specifying the operands is provided. So these are two operands. This information is followed by the destination operand separated from the source operand. So here we can see it's the source operand, sum is the destination operand. These are separated by comma. Now the sharp sign denotes an immediate operand. So we have discussed in the last lecture, the sharp sign indicates it is an immediate addressing mode. So add hash 5 comma R3. So it adds a value 5 or operand value 5 to register R3. Now the same, if it adds the number 5 to the contents of register R3 and puts the result back into register R3. So this instruction can also be written as add I 5 comma R3. Now I means we are using immediate addressing modes. So this equivalent code can be written in the form of add I 5 comma R3. So I indicates it is an immediate addressing mode. Indirect addressing is specified by putting parentheses around the name or symbol denoting the pointer to the operand. So as we have discussed, the same example, that is move hash 5 comma bracket R2. So bracket R2 can be written, means we are using indirect addressing mode. So it acts as a pointer to the, so R2 acts as a pointer to the operand. So it is called as an index register. So this can be written as move I 5 comma in bracket R2. So here there is no need to write hash. So in this session we have studied about auto increment and auto decrement mode. What is assembly language? Different machine instructions such as move and add. Thank you.